In this video, we'll be learning how to solve exponential equations. In a previous video, we learned how to solve basic exponential equations where we had exponential expressions with the same base. In this video, we'll be solving exponential equations where the expressions do not have the same base. Let's take a look at some examples. In example A here, we have 5 to the power of x plus 2 equals 3. Now, because 3 cannot be written as 5 to some power easily, we can't use the approach that we had taken before. What we can do, however, is use logarithms to help us solve this equation. Now, for this particular equation, there's two ways we can go about it. In our first approach, we can think what operations are being performed on the x. Well, we see that there's a plus 2, and then we have an exponentiation with base 5. So if we undo those operations, we can isolate x. So the first thing we want to undo is the exponentiation, which means that we want to perform the inverse operation, which is to take the logarithm with base 5. So we can start by taking the logarithm with base 5 of both sides of this equation, which gives us log with base 5 of 5 to the power of x plus 2. And on the right, this will be logarithm with base 5 of 3. Now, because exponentiation and logarithms are inverse operations of each other, and since these operations are performed back to back, we have that these two operations cancel out, leaving us with just x plus 2 on the left-hand side, and it's equal to log with base 5 of 3 on the right-hand side. So to solve for x, all we have to do now is subtract 2 from both sides. So x is equal to log with base 5 of 3 minus 2. So this is one approach for getting our answer. A second approach to solve our equation is to take the natural log of both sides rather than the log with base 5. Let's see what our equation would look like if we do this. We would have ln of 5 to the power of x plus 2 is equal to ln of 3. Now, if we want to proceed from here, what we're going to do is use one of our log properties. Specifically, we know that if we have an exponent inside a logarithm, like this x plus 2, it can be brought outside of the logarithm as a multiple. So we'll have x plus 2 times the natural log of 5 is equal to the natural log of 3. And now, if we want to solve for x, all we have to do is divide both sides by natural log of 5. That's going to give us x plus 2 is equal to ln of 3 divided by ln of 5. And then lastly, we just subtract 2 from both sides. We get x equals ln of 3 over ln of 5 minus 2. So this is the other approach for solving our exponential equation. Notice that although the two answers that we got here look slightly different, they're actually the same. Log with base 5 of 3 is the same as ln of 3 divided by ln of 5 according to our change of base formula. One advantage of writing our solution as ln of 3 over ln of 5 minus 2 is that we can type this into our calculators and get a decimal representation. So if we type this into our calculators, we see that our solution is approximately 1.317. Next, let's take a look at example B. We have 3 to the power of 2x minus 5 equals 2 to the power of x plus 3. This time, we have x's in the exponent on both sides. And we also notice that the bases are not the same. We have 3 as the base on the left, 2 as the base on the right, and there's no easy way for me to rewrite it so that the bases are the same. So to help us solve this equation, we're going to use logarithms. The question is, what logarithm do we take? If we take the logarithm with base 3 on both sides, that will cancel out this exponentiation on the left, but it won't cancel out the exponentiation on the right. If we take the logarithm with base 2 on both sides, it'll cancel out the exponentiation on the right, but it won't cancel out the exponentiation on the left. Since there's no way to get rid of both of the exponentiations at the same time, we're just going to take the natural log of both sides. That way, whatever answer we get, we can easily type into our calculator to get a decimal representation. So taking the natural log of both sides, we end up with ln of 3 to the power of 2x minus 5 on the left, and on the right we'll have ln of 2 to the power of x plus 3. Next, we're going to use our log property to take the exponents inside our logarithms and move them outside as multiples. So we'll have 2x minus 5 times ln of 3 equal to x plus 3 times ln of 2. Since the x's are no longer in the exponents, we've transformed our exponential equation into an algebraic equation. And to solve algebraic equations like this, all we have to do is move all the terms that involve x's to one side of the equation, move the terms that don't have x's to the other side of the equation. Now, in order to do that, we need to first distribute. We'll distribute the ln of 3 inside the parentheses and the ln of 2 inside the parentheses. This is going to give us 2x times ln of 3 minus 5 times ln of 3 equals x times ln of 2 plus 3 times ln of 2. So once again, we'll want to move all the terms that have x's to one side of the equation and move the terms that don't have x's to the other side. So let's move the terms with x's to the left-hand side. So this x times ln of 2 will move over to the left-hand side, and the negative 5 times ln of 3 that does not have any x's in it, we'll move that to the right-hand side. So we'll end up with 2x times ln of 3. And if we want to move this green term to the left, we need to subtract x times ln of 2 from both sides. So we'll have a negative x times ln of 2 on the left-hand side. And then on the right-hand side, if we want to move this red term over, we need to add 5 times ln of 3 to both sides. So we'll have a positive 5 times ln of 3 plus 3 times ln of 2. Now, on the left-hand side, we'll notice that every single term here has a factor of x. So we can factor that x out and get x times 2 times ln of 3 minus ln of 2. And on the right, it's still the same, 5 times ln of 3 plus 3 times ln of 2. And now all we have to do is divide both sides by 2 times ln of 3 minus ln of 2. If we do this, on the left-hand side, all we'll be left with is x, and on the right-hand side, we have 5 times ln of 3 plus 3 times ln of 2 divided by 2 times ln of 3 minus ln of 2. So this here is the exact solution to our exponential equation. Now, to get a better sense of what our solution is, we can always type this into our calculators. When we type this in, we get that x is approximately equal to 5.035 if we round to 3 decimal places. Let's work through one last example. In example C, we have 5 to the power of 2 minus 3x equals 7 to the power of 2x plus 1. Again, we'll start by taking the natural log of both sides. This is going to give us ln of 5 to the power of 2 minus 3x equals ln of 7 to the power of 2x plus 1. Next, using our log property, we can take the exponents that are within the logarithms and move them outside as multiples. This is going to give us 2 minus 3x times ln of 5 equals 2x plus 1 times ln of 7. So we've transformed our exponential equation into an algebraic equation. And so if we want to solve this algebraic equation, we just have to move all the x's to one side, move all the terms that don't have x's to the other side. So first we need to distribute our ln of 5 and our ln of 7 inside these parentheses. We'll get 2 times ln of 5 minus 3x times ln of 5 equal to 2x times ln of 7 plus ln of 7. So let's move the terms that have x's in it to the left-hand side. So this 2x times ln of 7, we'll move that over to the left-hand side. And then the terms that don't have x's will move to the right-hand side. So this 2 times ln of 5, that does not have any x's in it, we'll move that to the right-hand side of the equation. So on the left-hand side, we'll have negative 3x times ln of 5. And then if we move this green term over to the left, we need to subtract 2x times ln of 7 from both sides. So we'll end up with negative 2x times ln of 7. And then on the right-hand side, if we move this term over, we'll need to subtract 2 times ln of 5 from both sides. So we'll have negative 2 times ln of 5 plus ln of 7. Now, if we look on the left-hand side, we see that each term here has a factor of x. So we can factor the x out. This would give us x times negative 3 times ln of 5 minus 2 times ln of 7 on the left-hand side. And on the right-hand side, we still have negative 2 times ln of 5 plus ln of 7. Now, there's just one last step to get our x by itself. We just need to divide both sides by negative 3 times ln of 5 minus 2 times ln of 7. So when we divide, these factors will cancel out, leaving us with just x on the left-hand side. And on the right-hand side, we have negative 2 times ln of 5 plus ln of 7, all divided by negative 3 times ln of 5 minus 2 times ln of 7. So that is the solution to our exponential equation. And if we want to get a better sense of what our solution is, we can type this into our calculators. And if we do, we get that x is approximately equal to 0.146 if we round to 3 decimal places. So in this video, we learned how to solve exponential equations that involve exponential expressions that have different bases.